Goedemiddag. Hello, welcome, everyone. My name is Vincent Salucci, and I'm a program maker for the TU Delft Library. We're very lucky to be here this afternoon to discuss with the makers of the artworks that are recently installed in the Gen AI on the Fly program that we've been running this fall. And we have two interactive installations, one in the foyer, and this is People on the Fly, and one underneath our lovely cone. And this was Portrait on the Fly, and I think we'll talk a little bit more about them, but we'll certainly get to experience these artworks after the talk. And I wanted to sort of also invite people in the library that are studying, that we are having an event, so I would ask you to be respectful, but you're also welcome to join us, and you're also welcome to join us for the Boral afterwards, but you have to come to the event if you want to join us for the Boral. So that's the stipulation. And with the structure for the event today, we'll have a little bit of an artist talk, and then my colleague Cornelius Fragakis, who's the arts curator for the TU Delft, and also a library colleague, will come and begin the question round. I'm also happy to have the Emergence Art and Tech team joining us too, and so I'm sure they're going to fire some questions at our visiting artists and professors. So with that, I think I'm just going to formally introduce our presenters and turn it over to them. So Christa Sommerer and Laurent Mignonneau are internationally renowned media artists, researchers, and pioneers of interactive art. They worked 10 years in Japan as associate professors. I'm going to abbreviate just a little bit, and artistic directors. And so previously they were artists in residence at MIT CAVS in Cambridge, and artists in residence at the National Center for Supercomputing Applications, Beckman Institute in Champaign, Urbana, Illinois, and also artists in residence as well in Intercommunication Center in Tokyo. In 2004, they founded the Department of Interface Cultures at the Art Museum, the Kunst Academy, or the University of Art and Design in Linz, Austria, and they're visiting us from there today. So please make them feel welcome, and look forward to hearing more about your work. And I'm very personally excited to have them in the library and here today. So I've ran into their work on a more like personal side. I was in Brussels with my family, and I always go to the interactive and media galleries, and we ran into an installation that they've been showing a retrospective of works in various museums, and I ran to their work, and I was so impressed of how stable Laurent's media was, and also all the concepts and interaction. It was just such an enjoyable experience that I knew I had to get them to the library and to the TU Delft community. So thank you for being here.
So thank you so much, Vincent Salucci, for the wonderful introduction, and also for the invitation. Thank you to the library. It's a big honor for us to be here speaking in front of this wonderful book wall and this really amazing knowledge that is accumulated here, not just here, but also downstairs in the whole library. And it's wonderful to be presenting in a library. Thank you also to Cornelius, whom we just met yesterday. So it's really wonderful to be here, and we are looking forward to the presentation. And thank you to everyone who helped us here, also to Marcel and the whole team from the library. So we try to make it brief, about 30 minutes, and then we are very happy for getting Q&A. What we are going to show you today, I think Vincent already introduced us. We are both professors at the University of Art and Design in Linz, Austria, where we founded this master program called Interface Cultures. And we are both active in the field of interactive art since around 32 years now. And recently we had a big retrospective exhibition that was shown in Brussels, but also in other places. And we are going to show you a few of those pieces, not everything that would take too long, but a few pieces that we recently reconstructed. And what was also very nice here in this context, we see that you have a lot of people with technical skills and people from computer science and engineering. And you probably, many of you have also followed the development of technology, especially computer graphics maybe over the past years. And for some of you, maybe these works also look already quite historic, because we started out in '92 with making our first interactive installation. So our main focus is actually interactivity, and you see the two projects here that are interactive. And we also often develop new technical interfaces and physical interactions. You will see some examples later. And Laurent is also creating those algorithms and writing those computer programs by himself. And maybe just a short background information. I studied originally botany and anthropology, and later sculpture and art. And Laurent's background is video art, and he learned programming and electronics by himself. And so in one way or another, you will see that these different topics are resurfacing in our art practice. We are also very inspired by nature, so the projects that we will show you often have topics of nature, evolution, growth, swarming behavior, and often we model artificial systems that are also connected to natural living organisms. I show you here just the posters from the exhibitions that we had recently. The one that Vincent saw was at EMAL in Brussels, actually a very nice center if you're interested in art and technology. This was at the CKM, which in Karlsruhe, which is also a very nice media art center that also does a lot of art and technology. And most recently, this retrospective also traveled to Bilbao, where it was shown at the Azkuna Centroa, which is also a very nice art space in the center of Bilbao. I structured now our lecture a little bit around some more scientific topics. One is computer-human interfaces. Is there anyone here in the audience who is coming from HCI? Okay, so this is probably not so new to you, but in field of human-computer interaction, what we did, coming from an art background, we became quite interested in this idea of intuitive and natural interfaces, where people, or our audience, because we often make these things for like non-specialized audiences, where people can very intuitively interact with the piece of art. And one of our ideas is to use the human senses, like touch or vision or auditory input, and digitally enhance it by creating interactive scenarios where people can sort of engage with their full body into the artworks. And what we also like to bridge somehow is the digital and the analog world. And you will see this with the first work that we did in '92. This was, I think here we see a strong botanical interest. What happens here is we have 5 real plants put on pedestals and some light, some growing lamp on it. And when people, we see Laurent here touching one of the ferns, one of the ivies, and when he does this, he can grow similar plants on the screen. And maybe Laurent can explain you briefly how he's capturing the data from these plants, because what we experienced is when we have people interacting with this piece, they can always grow a different garden that is shown on the projection screen. And this garden, or this little sort of image of a garden, is changing as people interact. Do you want to briefly explain how you did this?
So very briefly, I'm not sure if I'm connected. Yes, I do. Yeah, so it's an interface that amplifies the electrical field of people. It also amplifies the electrical field of the plant, but it's the difference between the two. So amplifying this signal enables me to see if someone is close to the plant or not, and how far they actually touch. We all have different charges. Everyone is kind of an accumulator, charges all the time with static electricity. So the amplification is not discharging you. You don't get any shock. It's actually keeping the charge. It's very high impedance input. And each plant is giving some data, and therefore it's linked to the growth of these artificial plants that are based on algorithms.
So basically what we do, we pick up the microvoltage from the plant, and dependent on the distance of the human body to the plant, we get different voltage differences, and this data we are using to control the growth of the artificial plants on the screen. And this is what we discovered in '92 and have used this principle a few times already in other installations as well, because we discovered that it's actually quite nice in the installation that people start to touch, I show you maybe on the video, they start to touch real plants and then eventually see this translated into the growing of artificial plants on the screen. And even though you might not, I don't know how it was for you, Vincent, but maybe you don't completely understand at the beginning what's going on, but we realized that it's for people still quite interesting to get this sense of that their interaction input is leading to some changes on the screen, and eventually a new garden develops that can also be erased when people touch it again. We also did a second version of this, but with a different display, a little lighter, and with a kind of slightly vaulted screen with 3 projections and more plants hanging from the ceiling. Here's a shot from the Azcuna Centro in Bilbao. Here also many people at the same time can interact with the plants, and once they come towards the plant and touch it carefully, they see similar plants growing on the screen. So we had like ferns, we had the acapanthus, we had the peace lily, and different plants that would be displayed hanging from the ceiling. And as people touch them, as you see here now from the different installations, they would see similar growing plants on the screen. And Laurent also made an interesting effect that when the new plants are growing, they grow on top, while the plants that have been grown before, they are slowly fading in the background. So like this, you always have a new image and a new kind of garden that develops. You want to say something about this? The inspiration, maybe just to mention briefly, the inspiration was also Monet. Maybe some of you have seen in Paris the sea lilies, the sea roses, in the orangerie. So we wanted to have this screen that is slightly bent and feels like you're kind of mentally immersed into the screen. Then the next couple of projects I want to show you are more turning around the topic of artificial life. This is a topic we discovered in the early 90s also. There was a big conference in Linz. Maybe some of you have heard about Ars Electronica. It's a big festival in Linz, the biggest and oldest festival of electronic art in Linz. And we discovered artificial life in 92, 93. And we're also lucky to work with some of the researchers from that time. And at that time, we also became interested in using genetic algorithms and genetic programming techniques to produce images that are always changing and have also emergent features. And I think this is a very nice connection here to the emergence lab. Because we really like this idea of design that is not just done by us, but design that changes and develops and evolves basically when people interact with it. And this is what we came up with back then in the 90s. It's a pool, a real pool filled with water. And as people interact with the pool, they see some sort of jellyfish swimming around in the pool. And these jellyfish, they're quite abstract. They have been created by people who have been drawing some shapes on a touch panel. And once they look into the pool or even stick their hand in the pool, they can interact with these creatures. We call them creatures, but they're actually quite abstract. And these artificial life creatures, as I mentioned, they have been drawn by people. And then they have their own life. They develop, they move around, swim around in the pool. They mate, they prey, they evolve. And they have a kind of mini evolution. So we modeled, we were very inspired by evolutionary principles. And we modeled this system of evolution. But maybe to start, I show you here how they are created. It's a touch panel. You make a drawing, and your drawing becomes the genetic code for the creature. So depending on the parameters x, y, and z, these parameters form into a 3D shape, and the 3D shape determines basically the fitness. So if you make a good design, it's very fit and very fast, while if you make a not so good design, it's very slow, and this creature might be killed by other creatures. So the behavior of the creature depends on the fitness and on its energy level. This is the system setup. At that time, Laurent had to develop his own camera tracking system, but nowadays, of course, you can buy off-the-shelf systems.
In hardware, not in software. So it was hardware-based.
Yeah.
Computers were too slow at this time to do camera analysis. There was no way.
And then you can also touch these creatures by putting your hand in the water. This may be some details, just to, if somebody is interested, of how this interaction between the creature is determined by the fitness and the energy level. So as soon as the creature is born, it has a certain energy level that goes constantly down when it moves around. And if it's under a certain threshold, it becomes very aggressive and wants to kill the other creatures. And eventually, it eats the energy of the prey, and then it has enough energy to mate and make children. So there's a kind of simple, very small evolutionary structure where when two creatures mate, they reproduce, they cross over their genetic code. There's some mutation, some inversion and deletion, a little bit inspired by nature. And then the children creatures inherit the genetic code of the parents. And out of this relatively simple evolutionary system, you get a rather complex behavior among the creatures, and in addition, people can also interact with the creatures by putting their hand in the water and playing with them or protecting them. So here we see a creature being drawn, then immediately it shows up here in the pool. You have to really watch carefully what's going on, because even though there are not so many, it's not so easy to find out what they are going to do. But there is, of course, a logic to it. So it's a logic system. But the creatures, even though there are not so many, by their interaction with each other, display complex behaviors. Then this is what you might see in the pool. They are moving around. And as you can see, every drawing is different. Some maybe looks a little bit like a glass, the others looks a bit like a squarish object. Their sound is also coming from the design. So if it's a very small creature, it might have a very high-pitched sound. If it's a bigger creature, it might have a different sound. And here you see me interacting by putting my hand in the water. And if I put the hand onto the creature, it stops to move and it forgets what it wanted to do. So it becomes a little bit unattentive, but if you stop it too long, you use up the lifetime of this creature and it might die. So it's actually quite fascinating to interact with them and see and help them evolve, or to interfere in their evolutionary structure. Here's some more video. Okay, just to show you how the hand tracking is working. There's a camera on top that tracks the hand position of the user. This was the old scheme. So maybe it looks quite easy, but a lot of these pieces have quite sophisticated technology and also programming and engineering, especially since this was done in '94. Then I show you a few more pieces. This is phototropy. It's again dealing with artificial life. In this case, we have insects. We modeled like bees, butterflies, and some small moths. And here the insects react to the real light of a flashlight. So you have a screen where the user can just direct the beam of a real flashlight onto the screen. And then these insects come to the light. And when they reach enough light, they reproduce, they make children, again with genetic exchange of their genetic code. And the children insects look similar to the parents. And eventually you get more insects if you are very careful by directing the beam of your light. Or if you put too much light, they also die and you kill them. So here I think the also you had different iterations of technology in the early times. You had, maybe you can tell how you made it back then?
Yeah, since it was actually conceived in '94. Again, no camera directly connected to computers, so I had to come up with some ideas to track the lamp. But these lights that the lamps have, they are infrared as well, because this was like normal light bulbs. So that's the tracking is based on not a camera, but 4 sensors on the side with just infrared light sensors. And by triangulation, you can actually find out where the spot is. So it was not a very complicated setup, no cameras, no tracking like this, but actually only with 4 sensors on the corners, it was possible to actually find quite precisely the position of the spot on the screen.
But now you do it with the camera tracking.
I replace this because you'd have to be complete darkness with this with these sensors, and it was difficult to make that in every venue. So now it's based on camera, yes.
That's also a challenge when you're reactivating older pieces, say from the 90s, and redo them. Then, of course, we are not so strict about that it needs to be exactly how it used to be. We also change the technology and, update it, make it maybe simpler, but still try to keep the same aesthetic as it used to have. Here we see quite well how this person is directing the beam of the light. Then the butterflies come. Then the one that reached too much light, they die, or when he switches it off. But if he puts enough light and directs it carefully, then these insects come together. So maybe two butterflies come together, and they make a child insect that inherits the genetic code of the parent butterflies and flies in a similar way. Let's move on. Then this is a work I think that Vincent likes. It's a typewriter. It's a typewriter. Maybe anybody has still used such old school analog typewriter? Yes. We love old typewriters. We have a whole collection at home. And when we moved back from Japan to Austria, then we bought a lot of old machines on the flea market and then thought about what can we do with them. And Laurent had this brilliant idea of turning an old school analog typewriter into a computer. So he connected every key of the typewriter onto an interface. Maybe you can tell how you did it also and how this works.
Yeah, so basically the typewriter, well, it's a mechanical machine, but these are from 1930-ish, 35, 36. And of course, it's difficult to put electronics inside because there's no space in it. It was already a traveling version. It's very, very compact. So I had to deal with all the trackings with optical sensors. There's nothing touching the mechanics, and I tried to put it in. So all the keys, of course, are telling the computer which key you are pressing, but also the carriage and the scroll itself has to be tracked also as well. And so it's not done by a camera, it's really inside the machine. And then you have a projection on top that is projecting directly onto the page. The page is moving as you actually type. So you see the characters you type, but the characters are printed through the projection. So it's kind of a retroactive system where the tracking is done by the machine itself.
And here, maybe compared to the other pieces where you draw some shapes that look like fish, or direct your beam at insects that move on the screen, here the text that you type into the physical typewriter shows up on the piece of paper. It's a real paper, and then you see the text on the paper, but it's not from the machine directly. It's a projected text, but it's still the text that you type. But once you turn the carriage return of the physical typewriter, this text turns into a little creature that moves around on the paper. And these creatures, they also depend on the text. So the genetic code of the creature is actually the text. And we have a kind of algorithm. The ASCII code of the text is transformed into this design of these little creatures that look a bit like spiders, and they are buzzing around on the paper. And again, there's a logic to it. So if you write AAA, it makes a very simple creature, while if you write a little more complicated text, Then this creature has maybe more legs and more bodies and looks more complicated. And they move around, and they are also hungry. They want to survive by eating text. And if you feed some text by typing more text, they come and eat up the text and eventually get bigger and live longer. So again, there's this kind of life-like or simulation of life with the typewriter. And we were really also inspired by, surrealism, and maybe some of you have heard of Naked Lunch or William Burroughs. So this a bit creepy machine that is a typewriter that also does weird things, but also has a certain kind of logic to it. So we experience whenever we show this piece, people are very fascinated by exploring the functions of this old school typewriter and the enhanced function with the writing digital text and creating alive creatures. Maybe later we have some time for questions. Okay, I show you 3 more pieces. This is the one that we have here in the lobby at the entrance, and please experience it later. Just a little background information. This is relatively simple technology because it's a camera tracking and a software that Laurent wrote. And what happens here is it's again interactive. You have about 10,000 flies. It's pictures of a real fly that are swarming around randomly on the screen. But as soon as a person puts him or herself in front of the screen, detection, I think it's maybe you can explain later for those who are interested, a detection checks where is the person and detects the outline, the kind of contours, and wherever the flies detect a contour, they want to sit on it. And by this simple algorithm, you start to get some features and start to create a portrait of yourself. As long as you stay a little more longer than a few seconds, or I think 1 or 2 seconds, you start to see that the flies sit wherever you are staying a bit still. And like this, you can create your portrait. But as soon as you move, they go away again and disappear. And the portrait is a constant flux. We like also the fly. Maybe you know, especially yesterday we went to the Maurits house in Den Haag, and we saw a really wonderful still lifes of Abraham Mignon, and also other Dutch painters. And maybe you noticed sometimes in these beautiful still lifes, maybe you have some very beautiful flowers, but you also see a fly inside. And the fly, we didn't know that before, but the fly is, of course, in art history, a symbol of death and decay and memento mori. So often the artists at that time showed also their skills of painting skills by making most realistic flies and adding a fly here and there just to remind you, about the sort of, memento mori, like how life is short and please take more care of it. And so it has also this sort of a nice meaning by dealing with flies. And this was also an inspiration to us. And here you will also see, when you see the interactive piece, you will also see a few portraits. So sometimes we also make portraits of people by taking the image and then put it in our software and create a portrait, mostly from our media art friends and curators. And here in the corner over there, you will see also the portrait of Lynn Hirschman and Peter Weibel and Jascha Reinhardt, who are well-known people in the field of media art. I'll show you here the video. If you didn't try it yet, just a small introduction. So this was done in 2015. And it shows how the portrait is in constant change and flux, depending on how you interact and perform in front of the screen. But we encourage you to try it yourself later and take selfies or experiment with it. And the second piece that also uses the fly as a portrait is a work that is kind of the opposite of the portrait on the fly. It's called People on the Fly. It was recently also shown in Ascuna Centroa on a very big, large public screen in the middle of the entrance atrium. And here we have it in front. So if you're going to the coffee shop, you might run into it. And here the concept is that it's actually picking up the image of people live in black and white. And suddenly a lot of flies will follow you. So as soon as you move, they follow. But when you stay still, they go away. And so it's the opposite of the interaction that we have with the portrait on the fly. I show you here just a short sequence here as well. What we like about this version here is here it's often more like unintentional interaction, because you might just see yourself and don't know what's going on, but you are becoming part of the artwork without maybe even noticing. And especially when you do artworks in public space, this is a very interesting timing issue that you have to take care of. That people maybe not expect artworks in a library or in a such public open space. But it's also, oops, I think there was, I don't know what happened here. I have to cut this out. This is the other instance, as we had shown it in Linz, in the OK Center. We often show these works in a more like public space or in an atrium. And as you see here, as long as people move, these flies follow them. You have also this tracking algorithm. Maybe you want to explain the tracking?
I would not call it tracking at all. There is no tracking per se. In both works, the flies are completely free, but there are zone of interest. So for this work, is more the differences between the frames. So when you are moving, there is a zone where actually shows that the frame from before and frame from after is not the same. If you do the difference, you find some zones. And this is the zone of interest for the flies eventually to go there. So there's a lot of uncertainty about the way they will actually go there. I'm not giving trajectories or perfect way to land to that place. And that gives a little bit more liveliness into the system. So you don't actually see exactly how this flock of it's about 3,000 flies on that piece will actually go there, and why they are so interested in what moves. Over time it does. So, for example, if you move your hand for a long time, then all the flies will actually go there, but they don't detect it all at the same time, and it's also through their distance to that event that will drive them to go there. For the portrait and the fly, the algorithm is completely different for the piece that was shown before. It's just a random walk of all the flies. There are about 15,000 flies on the screen. And the only rules they have to do is to, if they find a pixel below them that is quite different to the one that they were walking before, they will just stop. And that means it's a zone of contrast because you have maybe an edge somewhere. And that's the only rule they have. And because they are randomly walking and because you are just in front of the camera, they will start to accumulate on that line and you will start to see yourself. So there's no tracking and there's no recognition of any sort. It's just out of this chaotic movement of all the flies that suddenly they do a very structured drawing of yourself. But you do the work actually of recognizing yourself in it.
And the last project, I think we are running out of time. The last project I want to show you is a very large public display. We were lucky during lockdown. There was 2 weeks of non-lockdown in Vienna. Maybe if you have been to Vienna, you know this very beautiful Museumsquartier, which is a very nice area in the center of Vienna with lots of museums. And we were lucky to use the facade of the Leopold Museum, where you find a lot of wonderful artworks by Schiele and Klimt and, you know, these very famous Austrian painters from the beginning of 19th century. And we were allowed to project ants onto the facade. So we had a lot of ants crawling around on the facade. And we also had an interactive station
in the
where
maybe
we don't need the sound. Can cut the sound maybe here. On the facade, we had these ants crawling around, and then there was also a camera interactive station where you could create your portraits created from a lot of ants. So there was this really kind of a bit creepy atmosphere of a building being invaded by ants, and then seeing your own face, a bit like here, being created from all these digital ends that are swarming around on the facade. And it was a very nice chance for us to also bring interactive art into a public space, and then, use the open space of a museum area for intervening with public art. So I think I stop here now and summarize. Yeah, we often have this artistic and scientific research practice. We often work with interaction and participation. Our interest is also to work with multimodal intuitive human interactions, and we have been often using generative art. And what we really like is work with the public and bringing people into the artwork, this idea of the open artwork, as Umberto Eco also defined it. And I think, as you have seen it, often issues of nature, plants, insects are used as motifs. And what we experienced also is that often people feel like through this interaction with plants maybe or insects, they also feel somehow attached to issues of the ecosystem and environmental issues. And I think that brings us to the end. And we will be very happy to have some questions. There's also a book here. Vincent has the book here if you're interested to find out about some more artworks. And I see already a hand raised here. Yes, maybe we can give you the microphone. There was a microphone.
Hello?
This is your water, Laurent.
You hear me? Perfect.
Yes.
So, sorry. First of all, thank you so much for your really clear and wonderful presentation about, well, compromising 32 years in half an hour, so chapeau. I had a few questions. I think you almost answered all of them. Because mine were not necessarily about the technical side of it, because I don't understand any of it, but more about the artistic side of it. Earlier today we had a wonderful conversation and we talked about the accessibility of technology and the change of it during the years. So I would love to ask you, how did the accessibility of technology change for you, and how did the way of working with this technology change? And so please, I would love to know.
Maybe a very short version. It was in the early 90s, as we talked this morning, extremely difficult to access good computers because nobody ever had any laptops, didn't really exist at the time. Good graphics computers were only in research laboratories. So we were lucky in the early 90s to be in a place that Peter Weibel was founding at the local art school in Frankfurt. And they had 4 computers. And we were about 20 students, so every day we could work 1 hour on the computer to get a shift. It was called a shift. So it was very hard to first get access to it. And then even if you had an exhibition and needed a computer, you would have to call up or actually fax to Silicon Graphics and ask them if you could borrow a computer, maybe for 3 days or so. So it was a huge effort just to show artworks on computers also, because they were not accessible and nobody could buy this privately. And we were quite lucky because first we had these computers at Institute of New Media, where we could access. Later we went to the US, to NCSA, National Center for Supercomputing Application, where they actually founded the first web browsers of Mosaic at that time. We were there when they developed this. And there we could work also on their supercomputers, but only at night when the researchers didn't need them. But we used it all night and slept only during the day. So that was nice. And then later we were lucky to went to a research center in Kyoto at ATR Research Center. And there, this was our first job. We were hired as artists in residence and as researchers. And there we even were able to buy our own, I mean, not our own, but the lab's computer. So yeah, this was the very long version. But later, of course, when PCs came up, when was this?
Beginning of 2000, changed.
Beginning of 2000, yeah, or actually mid-90s, I think, or late 90s. Yeah, I remember, yeah. then, of course, it became easier, and then you could access these machines much more easily.
That's a wonderful explanation. But the thing that struck me most is that I assume that it's easier now with all the accessibility of technology to create more difficult artworks or more challenging artworks, but you actually said the opposite was there. So you felt more pressure during the 90s to create, and with all the accessibility off-the-shelf technology, how do you deal with the immense availability of technology now and still to keep inspired by trying something new?
Mm-hmm.
Me? Okay. Yeah, I mean, still challenging to make projects with the available technology. Everything has changed pretty much since 30 years. So, of course, there are maybe other issues that you want to address with computations. But what we observed and what was the challenge 30 years ago was to make a very good plan for showing to people, yeah, it's worth, giving us a computer for that amount of time in the show because we have this and this and this inside. And so we had to really think a lot about the entire. It was challenging. I mean, the piece you saw with the water has a projector that is enormous below. It was like 3 CRTs. It's really, really big projectors at this time. They were 40 kilo heavy. And they had to be underneath the pool with a mirror, and everything had to be matching on top. It was a lot of challenges. Putting a camera on top, detecting the hands was not an easy deal. But all this was a kind of exciting moment because we thought, there's so much space there. You could really do so much with it. And so all this, of course, were not known to us before. And the algorithms to calculate the hydrodynamics in the water, in the simulated water, had to find out how to do it with the normals of the 3D design. The 3D design is not pre-designed, so therefore I'm just making an algorithm that came from another computer. I had to also do the communication language between the computers. There was nothing off the shelf directly, so a lot of things had to be solved to do that, but by doing this we learned a lot, and then this was then used for the next piece, and etc., etc. So actually these challenges were actually useful. It was good for us to learn, and I insisted of learning all these things by myself rather than trying to have someone doing it. It was not a strategy, but it's actually good because 30 years later I can still change the code and everything and still show this works. Otherwise, it would be just lost. And so it was just a challenge that we had to overcome. And maybe the attitudes towards the technology today from media artists is a little bit different. And maybe it has changed, that's for sure. I don't know if it's better or not, but can't tell.
Yeah, I have a question that I think ties in great with these last questions. You mentioned before that that you're not too strict on changing the techniques that kind of make the artworks work. But I can also imagine that in the past, the limitations have required you to come up with really creative solutions to the problem. And to me, that's also part of art, like the artwork. There's art in these creative solutions and updating them and maybe coming up with more, or implementing more off the shelf, more like easier ways. I was wondering if those implementations make you feel like there's value lost in the artwork? Like, how do you feel about that?
Yes, so Christa and me decided not to change too much the artworks when we present it again. So we allow to have the technology of today for projectors and all this because all the old things don't work anymore. It's really hard to maintain over time. And so the projection is changing. So for example, now we don't have these huge projectors for the pool, but we use very large 80-inch. It's almost the same size. It's very lucky.
A screen.
So, a screen below the pool. Doesn't really change so much the aesthetic. So as long as it doesn't change so much the aesthetic, we accept the change. The computers are completely different, but we don't see them, so it doesn't. Nobody noticed that they have been changed. And of course, you could do better. So you could do better, but we don't want to do better. We do better in other pieces. Then we start something else, and we try to do it with the technology of today, rather than trying to update them or make them more incredible. Because, well, it's a time stamp for us. We have been doing this at a certain time with a certain mindset, and you change after a while. So you could search forever, making it different. And for me, I know that I have to stop the research when the exhibition deadline is there. So I'm just doing this, and it's frozen. Whether I'm happy about it or not doesn't matter.
But I hope you're happy about
I'm
it.
usually fine.
Perhaps a small question leading on from that. Have you had a certain technology where, science evolves and digital technologies evolve and you're like, oh, if only I would have had that idea 10 years later and my life would have been so much easier?
Well, actually not so much.
You mean like that you would have wished that this technology existed already 10 years ago? Yeah.
Wheel, but
Yeah.
you could have used something off the shelf
Yeah.
or something.
Yes. Yes, this has happened sometimes.
Yeah, it has happened.
Well, we had to develop, for example, the Delft camera. Today, they are just around the corner. But in '96, we started to make Delft camera by ourselves. So we had to make the technology and the detection and all the tracking and all these things, not in the pieces that you have seen, but on other ones. And it would have been easier to use with a Kinect today, but it was not there. So we had to come up with some ideas how to do this with the current technology. We succeeded somehow. We had a system that actually nicer than the Delft camera of the Kinect today. It's actually more precise what I've been doing in the past. But it's not a product, and you have done this, and it's fine. But I learned a lot about how to detect things in space, how to find out where people are, but also having the picture of the persons in a distance without the technology that is used today, but with similar ideas. So that's interesting that you come up sometime with something that is used in the industry later. Like for example, tracking we also came up with some idea for making large interactive screens. And in the 90s, you had this amount of interaction. The screens were extremely small, but we wanted to have like a large screen. And there was nothing there available. And so I had to come up with a tracking system for 2 persons, but it was not available, so I had to do it myself. And this system is exactly what you are using today for making this kind of tracking. So it's very interesting to see how it became products, but it was not what I've developed, but a similar idea. So I think it's in the air. Somehow things happen here and there, and they develop differently later, become product or not. That depends.
I have a question for you, Laurent. Speaking of the research and the innovation phase and the sort of timeline and changes of technology, what are some of the technologies that you're most excited to work with right now and sort of down the rabbit hole researching?
I'm not exactly. Because I've been talking about technology, I look like I'm a technologist, but I'm not. I'm an artist, and I've been trained as an artist, and therefore I'm looking at technology as a mean to do something, but I'm not looking for the next thing that enables me to do some demo. So it's not the attraction towards the technology, it's more like which technology could fit our needs.
The concept,
yes,
it's mostly coming from a conceptual idea first.
And so therefore, I'm not quite sure what is attractive to me right now.
Well, sensing things in nature and, bringing ideas from nature into art and vice versa, artistic ideas back into nature. So this kind of bridging analog and digital is something that is going through a lot of our art practice, I would say. And of course, ecological issues is now much more maybe than it used to be in the beginning, that we often have this more need of doing projects that dealing more about ecology.
Excuse me, sorry. Using the plant as an interface and as
Yes.
such a simple interface. It's really striking. Here, do.
You mentioned that you started the Interface Cultures program at, I think it's at Kunstuniversität in Linz.
Yes.
What would be the one or two things that you teach to your students there, or say these are the most important things that I want to see in your work there while they are in the program at the Interface Cultures?
It's a very diverse program. So we have like courses on history of art, digital art, interactive art, but also courses on sensor technology, courses on media archaeology, courses on AI, critical data, then courses
Coding
on
as
coding. So
Sensors, microcontrollers.
sensors, microcontrollers, coding. Then it's trying to cover on the one hand technical skills, on the other hand also conceptual skills. And being at the purely art school, of course, the students are also immersed into other topics such as ceramics or painting or sculptures and maybe architecture. So they are really very much into the field of arts. And we are sort of the technologists within the art school. So students really come with a conceptual artistic approach to technology and then trying to realize their ideas or their concepts with these technologies. I think that's maybe different compared to a more technical school or technical university. Our students are mostly coming from these concepts about what they want to express. And I think it's not a simple answer. There's not like one subject. I think the most important thing I always think, especially now that students struggle quite a lot with AI, it's a bit suffocating for them because they feel like, oh my God, it's so difficult to find a new idea because AI is killing the creativity and anybody can do now art with AI. And so I think one of the big challenge is to come up with something that you really want to do, that has something to do with yourself as a human being, as a person with a history, as a person with emotion. And I think this is a real challenge nowadays for artists, to come up with something that they want to express and share with the world, and not just prompt quickly something on their computer.
I have a question about how do you come up with these ideas yourself? Like, how do you like to come up with new concepts? What do you do, or what are you searching for?
There is not really a recipe in a way, but I would say that it's a lot of discussions. Sometimes you go to a museum and you see maybe a Vermeer, or you see, like yesterday I was really struck by this in the museum in Den Haag. They actually, some brain scientists discovered that there is like a very clever way that Vermeer apparently had developed an algorithm or a kind of clever method of having the eyes and the mouth and the pearl in a triangle. So as a viewer, you seem to be trapped all the time, going back with your gaze between the three. And this is super clever. So this is a good inspiration. I don't know if we can do anything with this or if we can copy the Vermeer principle, but that could be really cool if we could invent or reuse or adapt something like this. But sometimes it's just a walk in nature and you're perplexed by maybe an insect that is climbing on a flower and doing interesting things there, So it could be anything that is can be an inspiration, and then we just bounce the ideas back and forth. Or Laurent is reading his Elector magazine, and then he's like, oh yeah, there's this new method, we could use it for something, and then it's maybe related to something that we discussed a few months before. So it's a very organic process somehow. And taking lots of notes and writing lots of things down. And eventually, then sometimes it's also good to have a deadline. Like you have an exhibition invitation and they want that on Monday you send the concept. And then you must make a quick concept, but you're based on all the things that you already collected before. So that would be maybe a method, I don't know. But sometimes the idea is not coming if you need it. So you cannot, it's not so easy to, you know.
It's emergent.
It's emergent, yeah.
So in a lot of things you showed, nature is coming back and also evolution. Is there an underlying thing you would like to tell with that? Is there an underlying meaning in it? Mm-hmm. Or is it just a coincidence that all the things are about nature and evolution?
Yeah, there are two things. Interaction is running after time, so the now. The now is always passing by, and you can really not catch it at all, ever. It's just the moment where things happen, it's gone already. So you always have a system where you are running after time all the time. And that's an interesting thing. It becomes an obsession somehow. You want to capture the moment where things happen. And that's the moment of creation. Creation is about that moment. All the elements start together and then make something. 5 minutes before it was not there. 5 minutes after, it has already a past. And so this moment is very interesting for us as creators because we want to capture that moment as wide as possible with all the possible events that you can capture. So it's probably a fascination. It's also maybe also a kind of obsession. For the time, at least for me. that's
I would answer a bit
feel.
differently, but
that's the way I feel. And so there is a space, a very large space where you can make experiments. You can't put everything together, but you have some moments where you can actually articulate that and make this event producing something. And this then becomes the artwork. So that's my interpretation. What's your interpretation?
Well, I think evolution is fantastic because it brings variation and variety. You know, you look maybe similar to your mom and your dad or your grandparents, but you are an individual and you look very special, you know. And I think that's so fascinating about nature. Like every leaf of every tree or every plant that you see here is individually different than other plants or other leaves before, and this I find incredibly fascinating. And this is also something we often try to have in the artworks to show this variation, and you can model this to some degree with algorithms.
Yeah, that's true. Yeah, it has all these elements of the opportunity, so things regroup. Then it has a history, so it keeps this form and then try to convey it to the next moment where things happen again. So that's a very interesting algorithm to explore. The only thing is what is difficult to make with evolution is the time. The time you can't really compress it, so you can't really jump forward. And so you have to get all these iteration, and the time for the visitor is limited. You can't count on, the visitor staying an hour to see something. So that also limits pretty much what you can do with it. But it's still within this small space. You can still make some experiments, and that's nice.
Speaking of time,
Yes.
please join me in thanking Christa and Laurent for their nice talk. And thank you for being here, and thanks to people that might be watching this talk online. And now is the time that we can all migrate towards the Borolce and experience the artwork and the interactive creations of Christa and Laurent. So thank you all.
Thank you.